Recitation problem 3. A rocket is moving at a speed of 45.0 meters per second. The rocket suddenly breaks into two pieces of equal mass, which fly off with velocities, as shown in the drawing. The question is, what are the magnitudes of the velocities of the two pieces, V1 and V2? Alright, clearly this is not an elastic collision because there is a damage due to the explosion. This is kind of the opposite of two objects colliding and sticking together. The rocket is initially moving along the X according to the diagram. It's going to break into two parts going in different directions. Clearly I need to break the V1 and V2 into components. V1 has two components, one along the X which is positive, and also another one along the Y which is also positive. V1 cosine 60 along the X because the angle is adjacent to the X, and V1 sine 60 along the Y because the angle is opposite to the Y component. Let's do the same thing for V2. Notice that the X component is positive. Let me write it down right here. I want to keep my diagram clean. V2 cosine 30. Cosine 30 because the angle 30 is adjacent to the X component, and it is positive obviously because it's pointing towards the right. However, notice that the Y component is pointing straight down, and that's the reason why it is negative, V2 sine 30. Now we are ready to start solving for the question. The momentum before the collision equal the momentum after the collision. Pi equals Pf. Initially I have only one object, which is the entire mass. Let me call it m. mv, v is the velocity of the rocket before the explosion, equals m1 v1 plus m2 v2. Vector equation. The next thing we need to do is to break this equation into components. X component, mv is nicely lined up with the X, therefore it is positive mv, equals m1 v1. Notice m1 v1 has an X component which is positive, m1 v1 cosine 60. The m2 v2 also has a component which is m2 v2 cosine 30. Y component, mv doesn't have a Y component, all of it is along the X, equals m1 v1 is positive. Instead of cosine here is going to become sine along the Y. Notice that the v2 is pointing straight down, therefore the component for m2 v2 is negative m2 v2 sine 30. Since m1 and m2 are equal, they should cancel here. m1 equals m2, which equals therefore the total mass divided by 2, right? Now let's substitute for the known quantities. X component first. You have m times v equals, instead of m1 I'm going to put m over 2. v1 cosine 60 is 1/2, plus, instead of m2 I'm going to put m over 2. v2 cosine 30, that's square root of 3 over 2. The mass here is going to cancel. Therefore, the X component, the v is 45, equals 1/2 times 1/2, that's a quarter, v1 over 4 plus, what do I have here? Square root of 3 over 2 times half. That's v2 square root of 3 over 4. The y component, we have 0 on the left hand side, equals, what's left? v1 times sine 60, which is square root of 3 over 2. v1 square root of 3 over 2 minus v2 times sine 30, that's 1/2. 1/2 v2. This is very easy and simple. We can cancel the halves. This half and this half gonna cancel. Isolating the v2, we obtain v2 equals v1 square root of 3. Now we need to substitute this v2 into our x component. X, have the 45 equals v1 over 4 plus, instead of v2, I'm going to put v1 square root of 3 times the square root of 3 over 4. Keep simplifying. 45 equals v1 over 4. What do we have here? We have square root of 3 times square root of 3, that's 3 divided by 4, that's 3/4. v1 1/4 plus 3/4 of v1, that gives you 4 over 4, which is v1. As a result, v1 is going to equal 45 meters per second. To finish the question, all we need to do now is substitute the v1 into the v2 equation that I obtained earlier from the y component, and the answer is going to be v2 equals 77.9 meters per second.